Hello, welcome to this MagiCAD for Revit webinar. Today we're going to be having a look at the use of MagiCAD for early stage electrical design. I'll be taking you through the basic workflow, but as this is quite a short webinar, we'll be going through at some pace. So we won't be taking questions during the webinar. If you do have any questions, please feel free to use the questions pane in your GoToWebinar control panel, and I will get back to you after the webinar to answer any concerns you may have. So to make a start on this webinar, what we'll do is take a look first of all at our project here. We have our usual training project. People who've seen these webinars before will be familiar with this, but essentially I'm going to take you through all of the early stage workflow. So here I have an electrical distribution strategy drawing, or layout if you will, and what I'm going to do is go through and show you how this can be configured to define phase areas and then also calculate some early stage loads for your project. So what we'll do first of all is have a look where those early stage loads come from. So in Revit, under the Manage tab in the MEP settings, we have the building and space type settings. In here you can see we've essentially got watts per meter squared values depending on building type, and then we also have space types as well, so you can drill into this with a bit more fine detail, actually define your spaces within your project as particular types of rooms, and then use watts per meter squared values for those, and get quite well, let's say a relatively accurate representation of the load for your building based on watts per meter squared figures. So Revit does this natively, but obviously defining that information can be a little bit tricky. So what I've done is I've created a space schedule, which is here. Once that loads up, there we go. And what this is, we have lighting and power loads here defined by the space type. So you can actually use this schedule to go through and set all of your space types throughout your project, and then that will give you some watts per meter squared figures for both lighting and power for each space. On top of that, we also have a MagiCAD parameter here for fixed loads. So this MC fixed load parameter, you can add fixed loads to these. So on top of your general lighting and power, you may have some equipment that you want to define as a fixed load, so you can add that to this parameter here. You can of course do that in the spaces themselves. If I click on one of these spaces, then you can go through the properties in here under electrical loads. You can click edit and then choose your values from here. So you can either use the actual space type itself, or you can use a specified value, and then you can choose either a fixed load or a load density for both lighting and power again. And then also in here we have the space type, which can be defined, and then further up we have the MC fixed load parameter in there as well. On top of that, we also have the ability to link these spaces to switchboards. So what I'll do is first of all start off by placing a couple of switchboards into the project. So here we go, switchboard, and then if I choose this generic main switchboard here, I'll not go through all of the details here. We've got separate webinars that go through the various features. So essentially you can configure the switchboard and then use our tools to install that. When you actually come to install these products, you always get this floating toolbar when it eventually comes to it. Within the floating toolbar, once it appears, there we go, you can actually define what your panel names should be. So I'm going to call this SB1, and that's going to be my main switchboard. Oops, I can't type today. There we go, so that's my main switchboard. In here, a small improvement over previous versions, you can also choose your electrical distribution system before you actually place the switchboard. This used to be an iterative process that was performed after you've actually installed the product, but now, as you can see, you can choose your distribution system from here, and then when you actually place that in your model, it will then automatically be set with that distribution system. So I'm going to choose another distribution board here. This is going to be my ground floor distribution board. So again, once it's finished building the Revit RFA for this product, it will again give me the floating toolbar. So again, that takes me to the actual install product feature. Again, we do, as mentioned, have a separate webinar on these things, and essentially the products in the data set exist as separate values. So they're raw data in the data set, and when you come to actually place these in the model, you'll see that it will actually assemble them into a Revit RFA. So you don't need to have all members of the design team using MagiCAD to be able to use these products. It is actually compatible with out-of-the-box Revit. I'll just finish detailing this, and then again choose the appropriate distribution system and place that in the model like so. So now I actually have some distribution boards in the model. Let me just double check my systems. Yep. Now I actually have those products in the model. I can then link these spaces to these switchboards, and that will then sum up all of those watts per meter squared values that we looked at earlier. In here we have the link spaces to switchboard function. This first asks me to detail which switchboard I want to connect these loads to, so DBG, and then I can choose to limit these to a particular phase if I wish. At that point, I can then choose the spaces that I want to link and then click finish, and it will link those to the switchboard. I've got a little Revit bug going on here which is stopping me from seeing it. Bear with. There we go. So you can see that's now colored those spaces in red. I can then use that feature again, and this time I'll choose just L3 and perform that function again, like so. And it's colored all of those blue, as you can see. Once you've linked your spaces to your switchboards, you can update the power data from the spaces, and it will push the information onto your switchboard itself. So if I now have a look at this switchboard, I can then see that my estimated load for phase L1 is so, and my estimated load for phase L3 is here as well. I've got nothing detailed for phase L2 currently because I've not connected any spaces to that switchboard using this feature, and then it sums that information up here in the estimated load. As you can see here, you can apply diversity factors to these. So if you want to diversify your actual board itself, then you can apply a diversity factor in here. And then you can do the same again with your expansion surplus. So if you need to allow 25% or so for future expansion, then you can put that in here in the form of a ratio. So that would be, in this case, 1.25. And then that will then calculate this with an additional 25% spare capacity. All of that information is then pushed upstream. So if I just update the power data once more. Now I've actually applied another factor. If I look on my main switchboard now, oh, it doesn't show me anything because I've not created a circuit. So I'll just detail this circuit, SB1, there we go, and then run that process one more time. So if I look at this main switchboard now, here I can see there's nothing in the estimated load because there's no spaces linked directly to this panel, but I can see here I've got a total estimated current and a total estimated load based on the values that have come through upstream from this distribution board. So using that philosophy, you can estimate your total building load. So when you're applying for a new connection, obviously you can see all of the information here and then use that data to apply for your connection. Excuse me. You can also use this phasing plan to then start planning out your circuits. So at a very early stage, without actually having any products in your model, you can use our Managed Circuits feature along with the switchboard schematics. So I have here some switchboard schematics, and these can be detailed at an early stage just for planning your circuits. So I can see here I'm going to require one overall circuit for all of the lighting in these offices here, and then if I go to my Managed Circuits feature and show panels from schematic, then it shows me DVG here, and I can say in this way I'm going to need choose a cable type first of all, installation method, and then you can detail single phase lighting like so. It can specify all of the various components in the circuit, and then you could even give that a load name if you wanted to. So if you want to detail that this is lighting for offices and then the numbers of the offices, so it could be 121, 122, etc. Then you'll be able to then determine the circuit once it's in here, and show which offices this is serving without actually having to create any circuits within Revit from the beginning. You can also specify in here, if I select multiple ways, you can choose your circuit numbering convention. So here I have a simple way and phase for a 3-phase board. If I click apply here, what you can see is it now numbers these 1L1, 1L2, 1L3, 2L1, etc. So when I'm actually planning out my circuits, I can do this without, again, having any products even, let alone circuits within Revit. And at that point, if I have a look on my switchboard schematic, it then starts detailing this information like so. I can then use that along with a calculation program such as Amtech Pro Design, for example, to actually start building up my network. So obviously I know that I have a main incoming switchboard, I've got a ground floor distribution board, etc., etc., and then I can see all of the circuits listed here. You can associate a load with each one of these circuits, so then again that starts helping you build up your overall calculation. Okay, so moving on, we also have some abilities to help you produce deliverables again. So here we have in our common tools, we have the spreadsheet export import tool. This allows you to export parameters. So if I have a look here, I've got spaces, and then I have a number of parameters that I can export with these spaces. I have actually created a list of parameters already, so you can actually save selection files. If this is something you do on a regular basis, say at the start of every project, then you can actually save these parameters into a file, and then you're not having to go through and dictate all of the parameters every time. What you can then do is specify an export file. So I've created this one earlier, but I can export this again. It'll do the same thing. And then once you've specified which parameters you want on the export file, you can export. And what that will do is then give you a spreadsheet that looks a little bit like this once it loads. There we go. So this is the spreadsheet. You can see here some of these parameters are grayed, and the cells are actually locked because here we've got area, which is a calculated parameter. You obviously don't want to change that because you could break Revit if you change that figure and then bring it back in, because it is calculated from the actual area of the space. So these are locked by default. And then here you can see the parameters that you do actually want to change. You have full control over. The green background, incidentally, dictates that this is a instance parameter. If any of these backgrounds were blue, then that would be a type parameter. So you can export type parameters as well as instance parameters. And then you can define the information you want. So in true Blue Peter fashion, I've made one earlier. If I just load that for you so you can see what I've changed. There we go. So I've just filled out the detail for this. I've put in my lux levels here, my luminaire types, and my control strategies as per some pre-arranged legends for each space. And then I can just take that spreadsheet, import that back into Revit like so. It gives me a preview here, so I can make sure that anything like area, which I know should be a calculated parameter and therefore shouldn't be changed, I can make sure that there's no changes. Any changes will be highlighted in red, so I can actually see here all of the changes that have been made to this spreadsheet or these parameters, and then click Accept Changes, and it will bring all of that information in. Again, Revit's doing its wonderful thing of not actually showing my color plans. There we go. So you can see that's now colored in my color plan as I would expect with all my lux levels. And then I've also created a tag here to show me the luminaire type and control strategy for each space. I can then, of course, put these onto a sheet and then I can bring a legend onto that sheet that explains what each of these parameters actually mean. And then that is my stage 2 deliverable done, essentially. So the same could be done with room data sheets. So if you wanted to do the overall mechanical and electrical strategy, you can add as many parameters as you feel is necessary to your spreadsheet export, detail all of that information, and then import that back into Revit. And then you can detail that with tags or color plans or however you want to display that information. So all of that is relatively straightforward. We also have tools which assist with later stages of design. So here in the electrical tab, I've got install product, and I may want to install some luminaires just as a kind of rough guide. So let's say stage 3 without any real calculations in place. I may want to detail some luminaires just to give the design team members an idea of what we're proposing. This is generally quite difficult to get exactly right when you're drawing this in Revit out of the box, because the placement tool is actually like point and click, so there's no kind of offset measurement for it. So here we have the array function. In here, I'm going to use select space. I'm going to use a number of instances. Let's assume that it's a plasterboard ceiling. So we don't have to align this with a ceiling grid. I'm going to have 2 rows and 1 column like so. And then I can just click into each of these offices, and it helps me place all of these luminaires very quickly and easily. And they're evenly spaced from the center of the room. I can then click apply, place those in the model. I can choose a different solution, choose a different room, like so, and so on. So it's very quick and easy to actually start detailing these spaces and placing luminaires in there. And as mentioned, when all of these objects are placed, once they're placed, they're essentially a Revit RFA, so they behave normally. You can move them as you normally would. You can circuit them up. So I'll show you an example of that quickly. So I can just create a power circuit there, choose the appropriate distribution board, like so, and it's a very quick, simple method of actually creating these arrays of luminaires within your model. We do, of course, have the Dialux export import tool. I'll be showing you that in the next webinar, so keep tuned for that one. But as we progress from early stage to detailed design, then obviously we can use the Dialux export import tool to export the geometry and then import the luminaires back into Revit in the correct locations. So when you actually have circuits in your model, obviously you'll need your containment. I've drawn some containment here already, but another tool that we have to help you detail your circuits is the cable packet tool. So what the cable packet tool actually is a modified form of conduit, and if I have a look at this, I can choose a system. So again, something MagiCAD brings into the electrical tools within Revit is electrical systems, which Revit doesn't normally have other than the obvious distribution system. So I can choose this type of conduit, which is called packet. It doesn't matter about the size because it's actually going to be kind of a notional route for my cable route, but I can use my alignment tools here to actually coordinate this with my containment that's already in the model, and I can select this this ladder here, and then I've allowed for an extra 25mm alignment tolerance on top of that. So then this is going to be drawn 25mm above the cable ladder here. And then once I click OK, I can then follow this through like so. I'm just being careful here to avoid clicking on the ladder itself, just because Revit loves to connect things together. So rather than have it accidentally connect this up to the cable tray, which will ruin the actual calculation process itself, I'm just going to detail this manually, and then it can obviously be moved afterwards over the containment as necessary. I'm just going to use another one of our alignment tools here just to do a 90-degree drop. So I can choose my angle, choose the height from the floor. So this might be 10mm off the floor maybe, just to represent the cable going down inside the unit, and then where it joins to the bus bar to give me my overall cable length. What we can then do with this cable packet is, once I've defined where the start point of the circuit is, using this function here, I can then use this to detail the overall length of the circuit from this distribution board here back to the main switchboard here. So Revit does make this assumption itself, but the method it uses is an orthogonal line. In Revit 2018 onwards, you can adjust the cable route, but it would have to be done on an individual basis for each individual circuit. So drawing this cable packet, what this allows us to do is connect multiple objects to the same circuit path, and then it will give us the overall distance, including any kind of working backwards like this here. So I mean, the distance isn't going to be too different using an orthogonal line here, but because it does return on itself for one portion, it is going to be maybe a couple of meters different. So what I can do here is I can create a cable packet connection between this distribution board and this cable route, like so. And then once it creates that connection in my circuit, I then get the Revit overall length, which is here. It's detailed as 30 meters, just about. And then I also get this parameter here, MC supply cable length, which, as you can see, it's a little bit longer, just because that system actually returns on itself at one point. So other than the overall cable length, the cable packet can also be used to list information. So that can be used for QA checks. And if I again go to one of our tools here, oops, MagiCAD Common, there we go. I'm just going to merge some parameters together. So again, this is yet another tool in our common tools. And what I can do is I can create circuit IDs based on existing information. So I'll update that quickly. I've just realized I've not actually set the circuit number. So I'll do that in Manage Circuits, and then here I can choose way and phase, 3-phase only, start from way 1, apply that. You can see there's a circuit number there, and then once I've done that, then I can run the merge parameter feature. There we go, circuit IDs. So the actual circuit itself now has a circuit ID, which should be the switchboard name. I'll just find it in the properties here. Yeah, so the switchboard name followed by the circuit number and ID, which hasn't come up. Okay. And then just run this one more time. Okay, so it still doesn't have it for some reason. There we go. That's what it should be. So once I have this circuit ID, I can then tag that information on the cable packet itself. So again, tag tool, I'm going to choose conduits here, and then you can see we've got various different tags that we provide with our localization pack to give you various information. So this could be the overall width of all cables touching if they're laid flat on a tray. The size would be the cross-sectional area. So if you were doing this as like a fill value within trunking or something similar, then you'd be able to use this to give you your overall fill size. Your weight, so we give you the ability to input the weight in kilograms per meter. So you'll be able to detail that as well if that's a concern for the amount of weight on the cable tray itself, or the hangers that are holding that cable tray up. Then obviously you can detail that information on there, and it will accumulate all of that information for the number of circuits that are on there. So using this circuit ID tag, I can show on this cable packet here. Once I update the cable packet, there we go. So I can show the circuit names that are actually attached to this. So this will actually change if I added another circuit at this point here and then put the tag here, then it would list 2 circuits then, and so on and so on. So as this cable packet goes further and further back towards the parent device, it will show you using these tags how many cables are attached to it, what the cable types are even. how many of what type of cable you've got, and so on. So we've got many tags that you can use along with that. Going back to our lighting layout for a moment, we also have another common tool in here which will help with early stage design, and that's the legend tool. So this can be used to create legends. If I type lighting legend, and then choose a template which can be defined again in the data set. You can choose a scale, text style, etc. And then when you click OK, it runs through, finds all of the elements that match your criteria, and then just creates a legend for those, like so. So you can define this template and how all of this information is presented in your data set. The data set looks something like this. And in here, there are a number of different options which can be set. You can store all of the common products that you use across multiple projects within this data set. Here, for example, you can see this is how the lighting legend would be put together. So these are the products that it will be associated with on the left, and then on the right here, these are the parameters that you actually want to export. And these can all be customized from shared parameters. So you can include or exclude whatever information you want from these legends. Okay, so that's all of the aspects that we're going to be looking at in this webinar. In the next webinar, we're going to be looking at how we progress from this stage onto more detailed design. So we'll be taking you through some of the other tools that we have in the electrical module, and also the advanced features of the managed circuits feature, which allow you to link the notional circuits that you created at this stage with actual circuits in your model, and then you can send your data back and forth between those. So I look forward to seeing you all in the next webinar, and if you, like I say, have any questions, then feel free to post them in the question pane. I'm going to be keeping this pane open for the next minute or so. So if you have any burning questions, please do ask, and I will get back to you after the webinar. If you do want more information, then please feel free to contact us. The information is on your screen now. There we go. So we are available through all of these channels. Please visit the website and you can sign up on there for more upcoming webinars. You can also view any of the previous webinars that we've done before through the links in the resources tab on there. And if you'd like to get in touch with us to arrange a demo or to discuss any of the details you've seen today in more detail, then please do get in touch with the using the information that's on the screen now. Thanks very much for attending, everyone, and I look forward to seeing you in the next webinar.